Magic, in the last video, you mentioned that machine learning needs historical examples to be successful. What on earth does that mean?
Exactly. So if you think about the term machine learning, it's the machine learning from examples. So before you can make machine learning work, you need to prepare those examples. You need to label them and then feed to machine learning so it will be able to figure it out what it's looking at.
So are we talking about algorithms that can identify the difference between cats and dogs?
It's the same technology. Just if you think about the business problems we talked about last time, like fraud detection or cross-sell or upsell.
Yep.
The data for it doesn't really sit in video files or images. The data sits in databases. And here's the problem. Machine learning can't really read the databases, and you need to reshape this data from database format to the machine learning ready format.
So you just can't go right to the database. You actually have to do something with it.
Exactly. And what you need to do, you need to pack all this database data into a form of a very specifically designed table.
Okay.
And the structure of this table is very archaic. And you need to follow 3 quite simple rules to get there. But it's not the understanding of these rules is quite simple. It's sticking to them, which is very, very hard.
Okay.
To the point that I would say these rules are the #1 reason for data science failing.
Did you just say the #1 reason?
Yes.
And because these rules are hard to follow, that's why there's these massive failure rates that KPMG and Gartner are reporting?
There are other reasons too, for sure, but this is the #1.
That's at the top of the list.
Yes.
Is the fact that these 3 rules are hard to follow. They're pretty straightforward, but they're hard to follow. You're going to need to explain this more to me because that doesn't make a lot of sense to me, Magic.
So how about, similarly to machine learning, I will show you some examples. And I will just walk you through a couple of tables and I will explain them.
Sounds like a great idea. Okay.
So here we are, Luke, with quite widely known repository for tables for machine learning. And why it's nice is because they sorted those tables actually by popularity. So I propose, to start with the most popular one, then walk through something else, and at the end I can show you a real-life table that we built for a project.
Sounds good.
All right, so I'm just going to flick to the table itself.
Of all the data out there, we're talking about irises. That's interesting.
Yes, this is a table. Well, this is actually, as you see, the most famous data set to the point that it has its own wiki page.
Oh, would you look at that?
So this table was first assembled in 1936, and the model was also built on it. So if you think about it, well before databases and well before the computing. So this is how the table looks like.
And this is the iris table that we're talking about here.
This is the iris table, iris data set.
Okay.
Let me just zoom out so you can see this is how it is. It's not that big.
This is not that big? That looks like a lot of information, Magic.
It's tiny. It has 150 records, and maybe best if we just maybe look at the sample. Okay.
Yeah, I'm getting lost in this already. Good idea.
This is a smaller version of it, just 6 chosen records from that table, and it will help us to explain what are we looking at. So we have 3 species of iris flower here. Iris setosa, Iris versicolor, and Iris virginica. And each of them is described by 4 parameters, and it's like petal length and width and sepal length and width. Are you with me?
I am, yes.
Okay, so I will use this sample table here to explain these 3 rules that you need to follow to prep the data for machine learning.
Okay.
So firstly, each flower has 1 record. So you store all the information about each flower in 1 row, in 1 record. You can't have 1 flower broken down into 2 or 3 records, and also you can't have more than 1 flower in 1 record, okay?
All right.
It's the same thing. So it's one example. That's our example. One example in one record. Got it?
Got it.
Then you have only one column with labels. So labels are those facts that we know of. These are the things that we want to understand or even perhaps predict in the future. In this case, it's a type of flower.
All right.
And all the other columns are called features. And they are used to learn about, what makes those flowers different. And there are also other names for these columns. So labels can be called target columns, and features are often called variables or factors or parameters. There's still a lot of confusion out there and different names.
So Magic, is there any significance as to how many features there are? Is there a minimum or is there a maximum amount of features that you can have on the table?
So the minimum number of features is 1.
Okay.
So that's what you need. You need only 1. And if you want even look at here at this feature petal width, you can notice that Iris setosa has very low values here. Iris versicolor is somewhere in the middle, and then Iris virginica has much higher values, right?
Oh, so right there, that is what is distinguishing between the different species of irises, is the petal width.
Exactly.
In this example.
Exactly.
Okay, well that is actually pretty straightforward.
It's a tiny sample, but actually if you look at the original data set, that's the truth of it, okay? It's one of the strongest features here in terms of differentiating between those 3 types of flowers. So now with that knowledge, we can maybe flick to another data set.
Yes, let's look at another one. Just give me an example what else it could look like.
So we have entirely different problem here.
What are we looking at now?
We are looking at early data about patients infected with COVID.
Oh, this is very timely.
In this case, we have around a little bit above 1,000 patients, and some of them died. So if you scroll here, these are the deaths here, and there are more of them. So let's just maybe zoom out here for a moment, right? So you can see it's a much longer data set, obviously, than Iris. Yes.
Much bigger, much bigger.
It follows the same 3 rules, right? You have 1 row per patient.
I see, yes.
You have our label here. That's the flag about death.
So in this instance, it's either they lived or they died. So it's the 0 or the 1 is about that.
Yes. And other columns are features that we may try to use to understand what is correlated with the risk of death.
Okay.
There's also patient ID, which is here and is not really a feature. So just to unconfuse you, this actually doesn't go to machine learning model. It's not analyzed, right? It's these 5 columns.
Right.
When you saw early reports that older people and males in particular are at the higher risk of dying, this is coming from this data or data shaped in that form. Once you have this data in that shape, then it's very easy to analyze, and machine learning can quickly figure out the profiles of patients at the high risk of dying.
I see. Okay.
So now, with that in mind, we can maybe switch to something we built on real life project.
One that we've Expanse has done on. All right.
Yeah. This is one of the tables. It's not the end table we've built. It's one of the intermediary tables for churn prediction. So what you see here is, again, 1 record per customer.
Right.
You have 1 column with labels. So 0 if didn't churn and 1 when churned.
Okay.
And you have a long list of features here that describe customer behaviors prior to those events.
So the label doesn't have to be on the right-hand side like we saw on the others. Whoa, my God, what? That's...
No, a label doesn't need to be on the right side. It's because when you work with machine learning, you specifically highlight which column contains the label.
Right.
And the machine takes it from there. So machine is not capable of figuring out, what are you trying to predict or understand? You need to point that out. And you know what, look, the data that you are looking at This is not how it's structured and stored in the databases. It actually violates some of the most important principles of database design. So you might say the principles that govern tables for machine learning are opposite to principles that govern database design. And that creates this requirement for all this work.
So on this table, we have...
It's around 250 features. So not too few, not too many. And it has close to 200,000 records.
You said 250 is not too many or not too small. Are you saying that there's more than 200, can be 250 features?
When you work on real life projects, there is often no limit to how many features you can create. The limiting factor is time, because each of those columns is a separate piece of code, and it takes time to build it, it takes time to validate it and execute it. And normally, you know, as I said, you can have one feature and try to build a model with it, right?
Right.
But it's highly likely your model would be quite poor. So we know that the predictive power is hidden in the high number of high quality features. And we don't know which ones are good before we build them. So we keep building them and we keep adding them, and we go from 100 to 500, then 1,000 and maybe more.
But time is a major restrictor here on how much data scientists can put into this.
Yes, traditionally this is where data scientists would spend, 2, 3, 4 months, sometimes even more than a year, and often they would fail as well, because they wouldn't be able to complete good enough table. Or very often when they start on a project, they actually don't know how to build that table, because all what they know is, all what was happening in the past was in the lab, they were handed over a table like that so they could start playing with machine learning immediately. And someone else put that table together. So what we saw, the repository,
yeah,
it contains hundreds of tables right now. And you can click and load them up quickly, and you can see this is another table. And the contents of that table and the features were built by someone else. And it's not a concern for a machine learning lab how this table arrived here. It's already here, so it's handy to start using. So when all your experience is, if all your experience starts with a table ready for machine learning, you don't know how to build it.
So you're actually telling me that data scientists walk into a job without knowing how to build tables?
As a rule, yes.
Am I understanding this correct, Maciek, that everything on the right of the green line that has some red in it are features that had to be actually constructed manually? This is somebody had to do these all individually? And you said there's 250 here?
Yes.
Well, how much time would that take?
Well, traditionally, that would take, for an experienced data scientist who know what he or she is doing, that should take something between 2 or 3 months. But the problem is, many data scientists have never done it, because it's not...
Because their tables were handed to them on a silver platter, and they didn't have to look at these, and they get into the real world, and now reality hits that they have to build these.
Yes. I think we should maybe talk about this in the context of a process later. This is one step of the data science process when you go from database to this table. There are other steps as well, but this is by far the most time consuming. And when you heard, 80% of project time takes data prep, well, this is it. This is going from database to the format of this table. That's the data prep.
I'm curious, do data scientists actually like doing this work and building these tables?
That's an interesting question. So, as a rule, probably not.
You're saying they're giving 4 to 6 months or longer of their time to build them. Surely they must like them.
I don't think they like to do it. And what they would like to do is to play with machine learning rather than, prepare the data for machine learning. It has to be done though. I met a few who actually enjoyed that process, but I think after, several projects, it just wears you down. The amount of work that needs to go into that. There's always some features that you think you should build up, but you run out of time. And it generally looks like a process that should be automated rather than executed manually.
Well, no kidding. Like, really. So much time, so much time spent just basically building the table before you even get to the machine learning. I think this is a good place to end the video, Maciek, because yet again, this has been very enlightening. And until our next video, take care.
Thank you.